Hello everyone one more time. So let's move forward. Let me share my firm belief that this week is crucial and the most critical, maybe from all the course, just this week. Some of you already know that concepts like conditions and loops, but this week is devoted to conditions, which is if, else, and loops, which is for, while, and so on and so forth. So maybe you know something about that, maybe not. This is make no any difference. The most important thing that you should know that. You should learn that. I really like that many of you, when we talk with you, you said, oh, I watched that additional videos, or yeah, I'm used that material. So please, if you do not understand anything, please jump into the additional materials, watch O'Reilly videos, watch our lectures one more time. But these two concepts, they are so important and so critical that you just can't move forward without that. This is just, I don't know, defining concepts for your programming future, let's say. Every programmer, of course, knows that, but the temptation is that if you do not understand that, just keep and just move forward and think, oh, maybe later I will understand that. Please, guys, please jump into these concepts and understand that concepts. Our assignments, I could admit, they are not so complex. It is not so much code for you to write in that assignments, but my advice to you, maybe write even more code, even maybe try by yourself. Some of you make great experiments, I like that. By the way, that Katya, yeah? So she showed increment for double numbers. For me, it was some mind-blowing stuff. So doubles, increment, decrement. So, and it works basically, of course. So make a lot of experiments. But please, make sure that you understand these concepts which we will talk today and on Thursday. So let's jump into that. This is my short inspiration to you. And let's just move forward. Oh, that's interesting why my picture is not working, but it is not so important. So conditions. Again, I already said that if you understand this week's topics, you'll understand programming. If you do not understand, this is a huge problem. Again, like with variables, but with conditions, conditions are everywhere. Let's admit that sophisticated behavior of our programs begins when it encounters a situation with more than one choice. You write your programs, you try input, output, but your basically chatbots is not so sophisticated. But when your program could generate different ways to solve the input values, to handle input values, then we have more than one choice, then we could decide. Then our program become more sophisticated, then our program become automated because, oh, because of that conditions, we will do that. Regarding that conditions, our decision will be another. So this is when our program starts to look like intelligent, but under the hood, we just have choices. I don't have really images in my presentation. That really weird. So let me check that it works. So choices. Choices, for example, when we go to McDonald's, first we encounter menu and we have many choices. This is the software system, and the software system is somehow programmed, and we definitely have choices there, and we could give our user the choice. For example, menu, we could choose chicken, Mac menu, burgers, drinks, desserts, and so on. So let me show you maybe example of that. Let's imagine the program. I hope this is proper window. Looks like yes. And let me just run this program. So welcome to McDonald's, scan voucher or jump to menu. What will be your decision? 1 or 2? You decide. 2, okay. What would you like? Burgers. 3. Okay. We have the following options. Big Mac, cheeseburger or Mac chicken? Which one? Big Mac or cheeseburger? Then I choose Mac chicken. Okay, your order, Mac chicken. Thank you for visiting McDonald's. So this is it. Not so sophisticated, maybe program, but still we have this menu, we have these choices. So how it looks like under the hood? What do we have here? So this program has, you see, a little bit more than 100 lines, and code is quite similar to from part to part, but let's just overview that. So welcome to McDonald's, println. Then we ask, enter your choice. We propose 2 choices to our customer, and then we read customer choice. So we introduce new variable with, by the way, meaningful name, and we read this variable from the line. Then we read next line symbol to just avoid any problems with input. And then we check this, basically this input, this variable. This is our first choice in our program. What user choose? If user choose 1, so you remember this equals, so result of this particular condition will be either false or true. So we have this if, English word if. Many of you, of course, use this if in your works, but some of you understand, some of you have experience, some of you don't. So we are introducing basically this if condition. So we put this English word if, then we put brackets, round brackets, and then we put Boolean expression inside that brackets. If this Boolean expression is true, then we execute this part of code, first part of code, starting from this bracket, ending with this bracket. Else, if we have another situation, we execute second part of the code. However, we start from complex example. In this case, we have another if inside our first if. I will explain it in a few moments, but let me just jump into other parts of this code and show you how it looks like. We have many ifs inside the if. So we could have this hierarchy of conditions. And because of that hierarchy, we could modulate sophisticated behavior of our program. So we could have branches. We come to root menu, then we could choose which way will we go. Then we have another ways, and all of that another if. And we could go through that ways. And so on and so forth. Of course, somewhere we should come together and somewhere maybe end the program or have different ends and something like that. I will show you how could we visualize that in more convenient way. But what we're talking about is if. Simple English word if. This is condition, and we have this syntax in Java regarding that. Okay, this is it. So let's now jump into if-else syntax. So again, we start with this word, and then we have this round bracket. So First, if. And now, guys, what's important here? Like on the human level, you understand that very well. If I choose burger, then program showed me burgers. And you understand that philosophically, let's say. But now you should be very precise, and you should understand every symbol on the whiteboard, every symbol on the screen. You should understand if, this bracket, this bracket, this bracket, and so on and so forth. So please be very curious and ask questions if need. So come back to our syntax. We open this round bracket, and inside these brackets should be Boolean expression or logical expression. We need Boolean result here. We need Boolean result. Boolean result we could have with such operators like equals, not equals, like or, and. You remember that, right? Regarding strings, we have contains, or again, equals method, and so on. It could be anything, but with Boolean expression, with Boolean result. Next, we open the round or curly brackets. To be sincere, we could even skip that and create if without brackets. I could println something, println, system out, println, hello, anything. And then I could write in other operators. By the way, one line of code which ends with a semicolon, we call it statement in programming, statement. This is expression here with some result, this is statement. So if I have just one statement here, I could skip curly brackets. And if will execute if true, if it is true, then it will execute this next statement. But this is not very practical. In real life, when we have this program in branches, we have not just one statement here, but we have some sophisticated logic in this branch. That's why we use brackets. And now you should become familiar what that brackets, because you already saw brackets in your program, right? Main, brackets. Class, brackets. We have a lot of brackets in C++ styled languages. What that basically mean? That means that we could represent for our compiler that many statements or lines of code inside my open bracket and closed bracket, all that could be as a one statement. So this is some black box. I don't know what inside of that black box, some logic, but I just abstracted of that, and I say when my brackets start and when it ends, everything inside, this is something which should be executed when true is inside if. Do you understand that? Because without brackets, we will execute just one line. We don't want to execute just one line. We want to execute all this block of code. So we call this many lines with these curly brackets, we call it block. So very logical name. Block of code. Block of programming code lines. Okay. Next. Let's write just some example. If, let me have variable int x equals 25. Now, please propose me to have some logical expression inside this if statement with a variable which contains variable x? Propose me something. If x doesn't equal, not equal 25 or something else, or no. Okay? So what result of this expression? False, because it is equal. Okay. But let me make it different to proceed with our lecture with our example. So if x is not equal to 5, what result of this expression? True. That's why this block of code will be executed. So I could println x is not 5, for example. And I could add many other lines if I want regarding my logic of my programming. Okay, so if it is understandable. Next step, any questions regarding this? Pretty simple, I agree.
If you have a double condition, like for instance, what you should do, like you have, for instance, less than 30 but more than 20, how it should.
Okay, let's write this double condition, not a problem. Good question. So again, any logical expression which gives us Boolean result. Let's try to do that. If x more than 5, for example, and what? And x less than 30. Is it correct logical expression? Looks like correct. So we have one logical expression, second logical expression, and logical end. What result of this expression? True. So you could put any logical formula here. Anything which gives us Boolean result. Anything. Okay. Then, any other questions regarding? Okay. Yes.
Does this syntax is correct?
This syntax.
Like, I mean, shouldn't we put in brackets this x?
Should we put this bracket here? Okay, good question. So regarding this expression, so the answer to this question, should we use additional brackets for logical expression when we want to combine some parts of this logical expression? For example, we want to make it more visible, more understandable, and even correct sometimes. The question regarding that is priority of operations. Compiler will go through all the symbols and will decide which priorities, in which order should compiler move. When we have these brackets, then we have decide what should be executed earlier, this or that. So regarding priorities, this should be executed first, this should be executed first, and only that after that should be executed this. Because you ask good question, because if we have that priorities, then compiler could think that it should execute this first, and then this, and then that. So this is good question. But priorities is such that this priority is higher than this. That's why good question. But sometimes it is better. It will not be mistake to write this like you propose with brackets. And even for humans, that maybe will be more readable. Yeah, so good question. All right, but we just a little bit slided into this logical expression subject. Let's come back to if. So we understand this overall idea if our expression is true. The question is, if this expression is false, what should we do? Can we handle that situation somehow? Yes, we can. How? You know that, many of you. Else. This is another keyword in this if. It is optional, so you could write your program without else. It is possible. Sometimes you just don't need that. But in many cases, you really need. And again, you could write it without curly brackets and just put expression statement here. Or like in many cases, you really need these curly brackets to not be mistaken. Like with this example with round brackets, the same here. And I could write else and write some code which will be executed if this expression is false. So we have basically two variants, two options here. Compiler come to this if statement, calculate this logical expression, get true or false. If compiler get true, compiler execute or runtime machine execute this piece of code. If this expression is false, then this piece of code will not be executed, but this piece of code will be. Pretty simple. Do you understand that? Let's move to our x25 example. Propose me something. If x bigger than 25, we output something, and else I open brackets here. By the way, you see I opened that on the same line, so you could write it in a bit different style, but I prefer this style. So, and here I write system out println x is not bigger than 25, so x is less or equal to 25. So, will this line be executed in this example? Yes. Why? Let's become a Java runtime environment. We come to this line. We check this expression. X bigger than 25. X is 25. 25 is bigger than 25. True or false? False, because 25 is not bigger than 25. That's why we skip this statement and we come to else statement, because in this expression we have else statement, and we just execute this statement. Do you understand that? Pretty simple. Do you agree? The most interesting stuff that, as I said, for compiler, for our Java runtime environment, all of that looks like black boxes. Let me explain me programming like I'm 30-year child. So, triangle, then this black box or red box, else, and what this circle. I like this. Basically, I use that approach when I explain CSS and HTML. Now I understand that we could use that even in programming. Welcome to our kindergarten, guys. Okay, so why not that a joke when some of our guys, maybe Vlad put that joke meme in our Slack channel with jokes when some children library, and that was some sophisticated subject, I don't know, so maybe artificial intelligence or some programming, some data structures for children or something like that. Data structure for kindergarten. So that was look like painful stuff, but you know, maybe we should move to kindergarten to explain programming. I don't know. Okay, just a joke. So what I want to say that for Java runtime environment, for compiler, this stuff, this and this is just something abstract. No, there is no any requirement how big or how small this block of code should be. It could be just another program, just another huge logic with many inner cases, with many inner ifs. What I mean? this this square could be another if. And we could have another logical expression inside this. It's absolutely okay. As long as we have these brackets, everything which happening inside, there is just abstract code. And Java runtime environment ready to execute that code. No problem. Let's come back to my example of, where is that, of code. You see, I have this if. This is my high level of my hierarchy with if statement. But inside this bracket, I have another if statement. Why not? And I could even put another if statement inside this if. And I could put more and more. And so on and so forth. I could build any hierarchy. So that's why you could think about this if like just entry point for more hierarchical logic. So that's why you should consider, now you could consider that block. This is new concept for us. And this is quite usable. This is quite good. By the way, how we call this bracket in Pascal? Almost, begin. This is begin. We just write this begin. And how we call this one? End. This is exactly sense. This is why creator of Pascal used these terms to bring. Pascal was created initially for teaching programming, to bring your understanding that when you open this bracket, you just started some block of code. Begin, end, and black box inside. And you could have many, many more begin ends inside of that black box. Okay. And the last trick with if-else, which you could see in my code here. You see many if-else, if-else, if-else statements. Let's come back to our x25 example. For example, if I want to know if x less than 5, then output x less than 5. But if not, I write else. But then I have new expression, because, for example, I want to check if it less than 5, if it less than 25, if it more than 25. I want to check where is my variable here. So I write else, and just here I could put if, or I could even make these brackets, but to make it more concise, we could just put if like this, and put another expression. Regarding this example, what you advise me to do? If I want to check this line, this part of a set of values, what next should I do? Yes, if x less than 25, I definitely know that x is bigger or equals 5 at this moment. Or I would not be here if x be less than 5, because I will execute this code and run out from this if. But now I check this part of the values. And again, I have these brackets. I could output that x kind of bigger or equal to 5 or less than 25. And I close my curly brackets. But else. And I could put more if I want to check 100, for example. If I don't want, I just could put x is bigger than 25, and that's it. So I bring your attention to this trick. but everything is just the same. Else, and then start new if, and go on and go on. Does it make sense? Okay? Especially look into these different branches, you could see the logic of that. Okay, that's funny position, man. Yes, problems with your back, maybe I could understand you. Okay. Yes.
So we have this variable order title. When did we declare it? Order title.
This next choice or what?
Order title.
Ah, this
Variable.
one. Mm-hmm.
Yes. So
Yes.
when did we declare it?
Yeah, good question. Regarding this specific code, we should, of course, should have this order title somewhere, and we declare this order title in the very beginning of this code. Yeah. Thank you for your attention. You will think like a compiler. Compiler didn't solve the problem, but you saw. Okay. Any other questions? Okay. That's fine. Now, let's move forward. Some questions. We see only part of the desk. Yeah, this is the problem. I should be more. I should see. Just help me with the desk to people to understand what part of the desk people online could see. Okay, now flowcharts. Flowcharts. This is a style of diagrams which is used in programming, which is used like in business processes. This is quite widespread stuff, and this is just very nice for you to know that, and especially this is the way how we create algorithms. Let me explain you how it works. And guys who are online, please let me know if you see this part of the desk.
Yeah.
Yes, okay. Amazing. How we create that? First of all, we create start ellipse. We create this, every flowchart, every diagram with conditions start with start. Okay. Next, for example, we could have input-output statements. So here I just declare that my variable will have value of 25, but you could imagine that I could read this value from keyboard, right? To give opportunity to my user input 25 or anything. That's why I could ask user, please input. I could even declare or make it more obvious in this diagram, input X. That means, so we have this kind of parallelogram here. That means that we wait either input or output. I put this input here. That means that in this case, that parallelogram means input value from the user. Okay, now I have X value. Next, I want to check if X less than 5. This is the most interesting figure for us. We call in English diamond this figure. So we have, I put arrows here, we have one input into this figure and two outputs, which is so important. One, please remember that, one input and two outputs. Not 3 outputs, not 4, not 10, just 2. Why? Because if have just 2 outputs, one output, second output. If I have additional condition, this is just another if, and that's it. Okay, what next? I have two outer arrows here, one true and one is false. If X less than 5, for example, in our program, we decide if X less than 5, we just output to the user, oh, you input value which is less than 5. Our program is so sophisticated. Output x less than 5. Output this line of code. So you see, here we have input, here we have output. That's I use parallelogram because I have output. Now, what should I put here, guys? I want to implement this algorithm. I want to draw this flowchart to implement these algorithms, to check either 5 less than 25 or less than 5, or what should I put here? Which figure? More than, yes, exactly. Diamond, yeah? So let's start from figure style. We just put here diamond. And what condition do we put into diamond? Good idea, but let's analyze that. We could put x more than, x more or equals 5, but do we really need that? We already know that it is, if I go this branch, I know that x is bigger or equal than 5, because it is just, because this is not true, then this is true, okay? I have no requirement, I don't need to check that. I already know that it is true. But what should I check here? X less than 25. And again, one input, how many outputs? 2 outputs. Let it be true here. By the way, I could choose either true not only on the left, you could choose how you want. But let it be true and false. X less than 25. For example, my program should just output this information that, yes, output x more than 5 and less than 25. Correct? Yes? And so on and so forth. If I want, I could check 100 if I want. But maybe I don't need to check it here. I want to stop. And I output, what should I output here?
X is greater than 25.
Do you agree? X is greater than 25. Or equals to 25. Yeah, this is it. Then, what should I do with all of that lines? I could bring them all together. And I could prolong, I could continue my flowchart to do somehow my flowchart. So, where is this? Yeah, I have this. This is it. You could open this flowchart on your computer if you come to this link. And this is diagram.net, which is quite useful, because in your assignments, you will draw this kind of diagrams. You should register there, but it is free. You just use maybe your Google account and to just log in into this service, and you could create this kind of diagrams. Yeah. So if this is end of my program, then it is end or finish, how we call it. This is just example. One figure is absent on my current flowchart. Is this figure, process. Sometimes we need to create just something. For example, I ask input x, but do I really have x? So maybe I need to put process here. Input x, and here I, for example, declare x. This is some process, just inner process in our program without input-output. And this is where we use rectangle. So rectangle is process. This is input-output. This is condition. This is end. This is start. So come back to my these definitions, all of them is here on this board. And you should be able to create this kind of diagrams. Okay, let's come back to our picnic example. Do you remember that? Britain picnic example. So let's think a little bit. Do you see anything? My awful handwriting style, but hopefully I will read it loud and you will understand. So start, then output hello user, then again input is raining. So I have variable is raining and I ask user to input this variable. Then I ask question, is raining true or false? If true, I output yes, and if false, then I output not today, we will not go to picnic. This is just for Ukrainian picnics, and maybe for picnic for every day, not only for Saturday. Just simplified version of condition, okay? Let's make it more complex. Let's remind ourselves that previous conditions which we had. What do we have? Start of the program, then input is Saturday, then input is raining, then input is Britain, and then introduce variable to go. We create new Boolean variable with name to go and assign value of false to this variable. Next, we have first condition. If is Saturday, for example, false. Then I round out from my if statement. I check to go. My to go at this moment will be false, and we do not go to picnic. Then, if it is Saturday, true, then I check variable is Britain. If is Britain true, then to go equals true, and I see we need one more line to go from here to here. It is absent here, this is mistake. If false, we put another condition, if is not raining. If is not raining true, then to go true, and so on and so forth. So please meditate on this flowchart. Do you have questions? Now, could I ask you, please, come for 2 or 3 people in teams and create if-else, create a code which implement this exactly diagram. Okay, this is your task. Please start to do that.